Hello, and welcome to our channel. Combining radar sensor speed data with license plate recognizing cameras makes a very powerful solution for traffic monitoring. Not only can you do detailed traffic flow analysis, but you can also generate alerts for excessive speeding, helping to make our streets safer. In this video, we'll show how to pass the speed messages from the OPS9243-A to the Verkada command dashboard. The architecture of the system consists of an OPS9243-A and Verkada LPR camera mounted with a view of a roadway. The Verkada camera sends its video data over PoE to the command dashboard. OPS9243-A sends speed data via Wi-Fi over MQTT to the cloud. These messages are received by a Node-RED dashboard, which reformats the messages with the appropriate IDs and tokens for receipt by the command dashboard. Once the speed data is received, further traffic analysis can be processed, such as reviewing traffic speeds at specific time intervals or calculating the natural speed of a roadway, the 85th percentile. Alerts for excessive vehicle speeding and their license plates can also be captured for follow-up by authorities. The first step is mounting your camera and radar sensor so they have the same field of view. The Verkada cameras have a wide field of view, 107 degrees wide in the horizontal or 43 degrees in zoom. OPS9243-A has a more narrow 20-degree wide field of view. Make sure they are focused on the center of the lanes of interest. On the OmniPresense website is a field of view calculator, which can help understand where the sensor is focused based on its height, angle looking into the road, and down angle. Verkada Command provides a simple-to-use, full-featured dashboard for viewing camera video and running analytics. To receive messages from OPS9243-A, the command dashboard must be configured to receive radar sensor speed data. As part of this development, unique IDs and tokens are generated, which are used in the speed message sent to the command dashboard. This allows command to know the data is trusted and should be stored in the dashboard. The steps for generating this information starts with generating an API key, which is unique to your Verkada account. Next, a Helix event is defined, which describes what data is to be passed into the command dashboard. When this is done, the message format is defined, UID created, and the URL that the message is sent to is provided. To start, click on the All Products box in the upper left of the command dashboard. Next, press Admin, which brings up a new screen. Select API and Integrations, followed by API Keys. Next, press the +Add button to get a new pop-up window. In this pop-up window, provide a name for your API key, and for endpoints, select Helix. Change the setting on the right to Read/Write and set the length of time this API key is active. Then press Generate API. Upon clicking Generate API, a new pop-up window will appear with the API key. Save this to a safe location, as we'll be using it later for the API token generation. Next, we'll create the Helix event, which defines what data we'll be passing into the command dashboard. Click on the Alert button in the lower left corner. On the new screen, click +Helix event. A new pop-up window appears. Give a name to your event and then add an attribute. We'll call the first Speed. The data comes in as an integer, so select Integer and then the Add button. We'll add another attribute for Direction, which is a string value, and add it. Future attributes may include vehicle classification or lane reporting. Finally, press the Save button. After pressing the Save button, you get a new pop-up which provides the format of the HTTP post message, which is sent to the command dashboard. Within this message is the URL that the message is sent to and the event UID. Copy the UID and the message format and save them, as we'll use them later. Note in the message it shows inserting the API key. This is not the API key previously generated, but an API token which will generate next. Next, we're going to generate an initial API token. Go to the Verkada website documentation titled Get API Token. Take the API key generated previously and put it into the box on the right side, labeled Header. Then press the Try It button. Below the Try It button will appear the response with a new API token. Save it as we'll use it later. Note, the API token is only good for 30 minutes. We'll use Node-RED to regenerate a new API token every 30 minutes. We're now done configuring the Verkada command dashboard and next move on to configuring Node-RED to format the speed messages. We'll use Node-RED for two main functions. First, formatting the OPS9243-A speed messages so Verkada command will accept them. And second, regeneration of the API token every 30 minutes. The Node-RED message formatting consists of three main parts. First, the message is received via MQTT. The message is in JSON format and is parsed. It is then validated, confirming it's a proper message with the speed information. Next, the message is reformatted in the form of the message template provided by Verkada command earlier. The URL, UID, and API token are input into the message. The message is then passed to an HTTP request node, which does a post to the URL provided earlier. A debug node is used to validate proper processing. The API token is regenerated every 30 minutes by using a timer which triggers a new message to Verkada command requesting a new API token. The message is sent via HTTP post and the response message is parsed to pull out the new token. The token is a global variable, allowing its automatic insertion in the formatted speed messages. Once Node-RED is configured, you're ready to validate speed events received within command. Select Alerts and then under Helix Events, the event created. When a vehicle passes, you should see a thumbnail video of the vehicle and below it the speed and direction reported. After this, you can set up alerts or perform other analytics on the speed data.